video covers Kirchhoff's first law, which is also known as the junction law, which states that the current flowing into a junction or division of wire will equal the total current flowing out of a junction. This is essentially a conservation of charge law, where we can say that the current just doesn't magically disappear or appear out of a junction. If I wanted to write Kirchhoff's first law in equation form, this is where it would look like, where the total current flowing into a junction equals the total current flowing out of the junction. So let's take a look at the diagram so you can visually see Kirchhoff's first law. We have the current I1, which is flowing into a junction, all right? And we also have current I2 and I3 that are flowing out of this junction. So Kirchhoff's first law will then state that this current I1 is going to equal the sum of the currents I2 and I3. Now let's apply Kirchhoff's first law to a circuit that actually has some values. We see that there are 5 amps of current flowing into this junction, and one of the wires has 3 amps of current. And we want to know what this missing current is. We know that Kirchhoff's first law states that the current flowing into the junction is going to equal the current flowing out, and the current flowing into this junction is 5 amps, and the current flowing out is 3 amps and our unknown current. And if we solve for this unknown current, we see that it is 2 amps. Now it could be asked, what is the current flowing out of this junction where the 3 amp and the 2 amp wire come together? So we know that the 3 amps and the 2 amps are going to be coming in, and we're looking for this unknown current coming out, which, just like before, is going to be equal to 5 amps. Next, we will want to find the current in all of the wires in the circuit below. We know that there is a current of 10 amps going through the wire that is labeled green, and that the current flowing through the blue wire is 4 amps. All right, and we are going to be looking for this current in the pink wire. We know that the current flowing into the junction is the 10 amps that comes from the green wire, and the current flowing out of the junction is going to be this 4 amp wire, that's blue, and also our pink wire. So we know that 10 is going to equal 4 plus the current in this pink wire, which we know is going to be equal to 6 amps. Alrighty, so next, let's say we have this purple wire here that has a current of 5 amps. We could then be asked what the current is in this red wire here. So we know that the current going into this junction is 6 amps, and that the current coming out is 5 amps plus this unknown current in the red wire. So 6 equals 5 plus I, we know that this unknown current must equal then 1 amp. Alright, we could then also be asked again, what is the current through this pink wire when the 5 amp and the 1 amp come together in a junction? So we know that we have 5 amps of current and 1 amp of current coming together, and that means that that current together must equal the current coming out. So this once again is 6 amps, just like the wire before. And once again, we have this 4 amp blue wire coming together with our 6 amp pink wire, and we know that the current going into this junction is 10 amps, so once again, our green wire here is going to have 10 amps of current as well.